Welcome to the second lecture on conic sections. So our today's topic is circulars. Before going to the algebraic equations of circulars, let's see how we can obtain the circle from a cone. Here I have a double napped cone in my three-dimensional space. If I cut this cone with a plane such that the plane is perpendicular to the axis of cone, then we get the intersection as a circle. So here is my circle. So as long as we have the angle of intersection as the angle of the plane perpendicular to the, or we can say the normal to the plane parallel to the z-axis or the axis of the cone, then we get a circle. So this is how we get a circle. Now let's try to see how algebraically we can derive the equation of a circle, how we can represent a circle with equations. So the definition of a circle is a collection of all points x comma y such that the distance of these points from fixed point is constant. As we move along the boundary of this circle, its distance from its center is always fixed. So I have a center with the coordinates h comma k and an arbitrary point x comma y on the circle. So the idea is the distance between these 2 points is always fixed. With the distance formula, I know the distance between these 2 points is, this is how we can calculate difference in x coordinates and their square, difference in y coordinate and their square, and the square root of all these things. This is the distance between these 2 points. And we know for this, this is the radius of the circle. This is r, and r is positive here. So getting rid of the square root, we get x minus h whole square plus y minus k whole square is equal to r square. This is the general form, standard form of equation of a circle, where h and k represent the h comma k ordered p represent the position of the center, and r represents the radius of the circle. So let's try to solve a question based on this information. The question is saying find the equation of a circle with center 0, 0 and radius 4. So h comma k is 0, 0 and r is 4. Our general equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. Putting these values here, we get x minus 0 whole square plus y minus 0 whole square is equal to r square, r which is 4 square. So if I simplify this, I get x square plus y square is equal to 16. This is the required equation of a circle. Let's move to the second question. The second question says that find the center and radius of a circle whose equation is given. Now, we are given the equation. Now our goal is to find center and radius. So how we can do that from the equation? So we have to convert this equation into its standard form. Then we can extract the coordinates of a center and the radius. So we know that the general form of the equation is x minus h whole square plus y minus k whole square equal to r square. We have to convert this equation into this standard form. Let's see how we can do that. If I write x square plus 8x plus y square plus 10y equal to 8. Now I will try to combine the terms by completing the squares. This will be x square plus 8x plus 16 plus y square plus 10y plus 25 equal to 8 plus 16 plus 25. I added 16 and 25 on both sides. So this will be x plus 4 whole square plus y plus 5 whole square equal to 49, right? So this sum will be 49. If I write in the standard form, this will be x minus of minus 4 whole square plus y minus of minus 5 whole square equal to 7 square. So from this, we have our center h comma k to be minus 4 comma minus 5 and radius r 7. Fine. Now moving to the next question. So the next question is saying that, so we'll solve this from scratch. The question is saying that find the equation of a circle which passes through the points 2, -2, 3, 3, 4, 3, 4, and whose center lies on the line x plus y equal to 2. So how can we solve this question? All we are given that the center lies on a curve, which is a line, and 2 points through which the circle passes. We know the general equation of the circle is x minus h whole square plus y minus k whole square to be r square. We are given that if the circle passes through these 2 points, then this equation must be satisfied by these 2 points. So the first thing is 2 minus h whole square plus minus 2 minus k whole square is equal to r square. So if I simplify this, this will be 4 minus 4h plus h square plus 4 plus 4k plus k square to be r square. This is my first equation. Now I have another condition of that the circle passes through 3, 4. Then the second equation will be 3 minus h whole square plus 4 minus k whole square is equal to r square. So our goal is to find h, k, and r so that we can identify, uniquely determine the equation of the circle with this. So this will be 9 minus 6h plus h square plus, expanding this term, we will get 16 minus 8k plus k square to be r square. This is my second equation. My third equation will be that the center lies on y, x plus y is equal to 2. So let's try to use this information also, that since our center is h comma k and it lies on x plus y is equal to 2, then this gives me h plus k is 2. So this is my third equation. Now, if I combine first and second, what do I get? Combining 1 and 2, we get, then here we have r square, here we have r square. R square is here, r square is here. Equating these two terms, we get 4 minus 4h, h square and k square will go, plus 4 plus 4k is equal to 9 minus 6h plus 16 minus 8k, 8k. So if I simplify this, this will be 2h plus 12k is equal to 9, right? Simplifying this, we get 17, right? So this is our fourth equation. So what do I get? 4 plus 4 is 8, and I'm canceling the things, shifting h here on the right side, left side. So the goal is to simplify this, and we get equation in terms of h, k, and r. So if we solve these equations, we get if we solve these equations together for h and k, now combining 3 and 4, not combining from 3 and 4, from 3 and 4, then we get h is equal to 0.7, k is equal to 1.3. From this we can calculate r square, right? And this will be around 12.36. R square is 12.36. So all our parameters we can find from these three equations.